Okay, so for this problem right here, it gives us a table of months and their maximum temperature in degrees Fahrenheit. So for part A, it says use a graphing utility to plot the data and find a model for the data of this form given right here. So T is the temperature and the small t is the time in months with T equals 1 corresponding to this January, this first point right here. Now it says round all numerical values to 2 decimal places. It's asking what is a temperature of T as a function of time. So whenever you're given data like this, you're going to need to go to something like Desmos because this is going to make your life easier. You'll see why. So on Desmos, you can plot things. You press the plus sign, you go to the table, and then you can put in any points for X and Y. So my X-axis is months, and then the Y-axis is temperature. So when we plot this, we see the points, it kind of resembles like a wave, almost like part of a sine wave. And so now with the power of Desmos, we can approximate and get a function that closely touches all these points right here, that gets close to this right here. So we do that by putting this y1 right here, squiggle to signify approximate, and then we write the form. So a plus b sine of ct, but then it's represented by x1 and then minus d. So this gave us a function just like that. You see it looks pretty close. It's nice. So that's what it looks like, and we have our parameters here. So I've already copied this down and I wrote it here. So I'm going to stop sharing. So I wrote down the function here. So that is part A. That is your first answer right there. And now it says find t prime, and then use a graphing utility to graph its derivative. Okay, so now in here we need to take this derivative. So this is a constant. The derivative of a constant is always 0. And then we look here, there's some weird things going on. This isn't just sine of t, there's other stuff going on around it. This is a function inside a function, and this calls for a chain rule. So when you have a function inside a function, you have to take the derivative of the outer function first, then multiply it by the derivative of the inner function. This is an example right here. So now let's determine what t prime is. So that's 0 plus 27.27, and then derivative sign is cosine, and then the argument inside of these, they stay the same, they don't change. And you multiply it by the derivative. So the derivative inside is 0.49. That is the derivative of this. So this is our t prime at t. Now it says we're going to have to graph this. So again, let's go back to Desmos. Give me a second here. Okay, so we go back to Desmos. So first of all, I'm going to go ahead and put in the original function right here. This is our original. Temperature is a function of time in months. So now what we can do is I call this function t. So now I could take t, put an apostrophe to signify prime, and then put an x there, and it'll take the derivative of this and plot it. Okay, so now let's put in the derivative function that we came up with, and let's see if they match up. Times the derivative of the inside. And you see, it matches up. And so that's all there is for this problem.